Hello everyone and welcome to Nanobar. Well, brothers, today's script is really interesting. We all know that AI is a big party right now, but this party has a fatal problem. It's a money pit, and specifically a resource money pit. These tech giants, especially Google, are getting electrocuted by the power demands. Why? Because AI training and data centers consume electricity, water, and land. School plans to pour $85 billion into data centers every year. Now, this is interesting. On one hand, you're spending all this money, but on the other, aren't you claiming to be an environmental pioneer? Remember Google's previous commitment to achieving net zero emissions by 2030? Hey, if you check their official website homepage now, it's gone. They quietly removed this commitment from the homepage and tucked it away in an environmental report, calling it a moonshot. Moonshot? That's a good word choice. Isn't that just the official way of saying drawing a big pie in the sky? This clearly shows that even they've realized that even they keep competing like this on Earth. Scaling AI and achieving net zero emissions are two things they simply can't pull off. So, if they can't compete on Earth, what's the solution? Google's script has arrived. Project Suncatcher. In plain English, it means, we're not playing with you on Earth anymore, we're launching our data centers into space. And you know what? The PowerPoint presentation for this is really impressive. Energy? There's inexhaustible solar energy in space. The orbit they've chosen allows for 24/7 sun exposure, and the power generation efficiency is 8 times higher than on Earth. Cooling? Space is a vacuum. On Earth, data centers need water towers to blow air, but in space, they even save on water. Hardware? They'll use their own TPU chips. From hardware to software, they want to create a Google Space family pack to achieve vertical integration, avoiding paying NVIDIA any tolls. Wow, that's some impressive maneuvering. They've even found partners, a satellite company called Planet Labs, and they're planning to launch 2 prototypes into space by 2027 to test the waters. Doesn't that sound seamless? Google's Suncatcher plan sounds incredibly ambitious, but it has one fatal prerequisite: launch costs. School did some calculations, and for this to be economically viable, not just a PowerPoint dream, the cost of sending things into space must drop to below $200 per kilogram by the mid-1930s. What are the current launch costs? Google itself stated it's more than 10 times this target price. Even the cheapest Falcon 9 still costs $1,500 to $3,000 per kilogram. So how will this dream of $200 per kilogram be achieved? Google's entire business model is completely, utterly, 100% dependent on an external factor, Boss Ma or Elon Musk. Because Boss Ma's big rocket is currently the only launch vehicle in the world that dares to claim it can bring costs down to below $200 per kilogram in the future. Brothers, I'm truly dying of laughter. To solve its AI crisis, Google has drawn up an astonishing space data center pie in the sky. As a result, whether this pie can actually be eaten depends entirely on whether one of its biggest competitors, Boss Ma's SpaceX, can first bake the pie. Google's Suncatcher is not a moonshot at all. Boss Ma's Starship is the real moonshot. Google's project, at best, is just an app that's gonna run on Boss Ma's system, and they're still writing the PowerPoint for it. And you think that's all? Even if Boss Ma delivers, Google's own PowerPoint has plenty of black holes. First, heat dissipation. They say that a vacuum doesn't require water cooling, right? But there's no air in a vacuum. The thousands of watts of heat from your TPU chips can't be blown away. They can only radiate out slowly. This is extremely inefficient. What's the solution? Google subtly avoided this problem in their paper, simply stating, we'll use heat pipes and radiators. This is as good as saying nothing. In engineering terms, this means your satellite would need huge heat dissipation panels. These panels would be large and heavy. So wouldn't your launch costs go up again? Doesn't that just bring us back to Boss Ma? Second, networking. Google envisions a cluster of 80 satellites. For them to transmit data at high speeds using lasers, these 80 satellites need to fly very close to each other. How close? 1 kilometer or closer? Possibly even only 100 to 200 meters. My goodness, 80 chunks of iron, flying at 28,000 kilometers per hour, playing chicken with each other. How is that different from playing bumper cars on the highway? So, Google's Suncatcher is currently a gamble. They're betting that solving the physical problems in space is easier than solving the political problems on Earth, such as power grids, water resources, and carbon emissions. But Google isn't the only player in this supercomputing game. Boss Ma isn't waiting for you at all. He has already publicly stated that he will carry data center functions on his Starlink V3 satellites. He's building rockets, delivering packages, and even running his own supermarket. Microsoft is the slyest. They're doing Azure Space. They're not building satellites themselves. They're acting as a platform provider. They're putting their cloud services on other people's satellites like the International Space Station. China also has its own efforts, and it's a national team effort, the three-body computing constellation. The goal is 2,800 satellites, which is no small feat. It's a national strategic asset. And there's a bunch of reckless startups like StarCloud that want to send leather jacket guys H100 GPUs directly into space. As you can see, this game is getting very lively. But ultimately, Suncatcher is just a prelude. All these space supercomputing dreams, including Google's and China's, all depend on one thing. Boss Ma's big rocket, Starship, must succeed. If Starship succeeds and launch costs come down, then Google's plan is feasible. If Starship fails, or if costs don't come down, then these will just be an expensive scientific experiment launched in 2027, pure and simple space junk. So, don't just focus on Google's AI press conferences. To understand the future, you need to keep an eye on Boss Ma's next Starship test flight. That's Google's true lifeline. Alright, that's all for this video. See you next time.